Hi! You're going to study this module to help you learn about Newton's first and second laws of motion. This module will make you realize that most of our actions and activities every day are related to these laws. This was based on your diverse experiences and prior learnings. So, enjoy it! After going through this module, you are expected to in doing things like household chores, playing, and marketing, amount of force applied is a factor to make our motion fast or slow. Example, in arranging your furniture, you usually push or pull it. Techniques are important to overcome friction and inertia for a fast movement. In helping a driver pushing his vehicle's stack of sticky mud or when engine stops working depends on the magnitude of forces from the people pushing the car. You have learned in your previous lesson that the layman's understanding of a force is that it is a push or a pull, which refers to a very specific action. Force acts on an object. This implies that when we pull or push, there is an object that receives it. For force exerted on the object has a magnitude and direction. That is why it is a vector quantity. Examples: 5 newtons up, 2 newtons east, 6 newtons down. Newton is the unit for force. You also learned about net force. Net force refers to the sum of the forces acting on an object capable of changing the object's state of motion. Let me illustrate the net force. This ball is acted by forces with different directions. Its net force is equal to 2n, right? The direction of the net force follows the direction of the force of the greater magnitude. Another ball is acted by forces of the same magnitude and directions. The net force is equal to 8n left. Did you find the difference on the two examples? Another important concepts you need to be refreshed are the following: tension force, friction, normal force, So, I think you are now ready for our engaging activity. Study the pictures. Give your observations regarding the force exerted by the grocery goers in pushing the cart and the contestants in pulling the truck. You may pause the video to give you time to observe the pictures. Let us explore the concepts by performing activities. In our first activity, to explore the concepts, you are going to see the videos. These are about a game of 2 teams. But try to read first our objective for this activity. For the procedure, The red team and the blue teams are to pull the cart full of groceries to be used during the enhanced community quarantine due to COVID-19. The winner, after the final round, will take the groceries home, study the series of videos, and be able to determine what makes the winner wins the game. You may pause the videos so that you can understand it. Summarize your observations in table form. So this is the table. First round, second round, third round, and the fourth rounds are found in the first column. In the second column, you are going to write the total magnitude of force exerted by its team, blue team, red team. Then there's a question on the third column. Is the force equal? You're going to answer this yes or no. And the last column, there is also a question. Will the cart move? Answer it yes or no and determine to what direction. Take note, you need to record in the table the magnitude of the force exerted by its team and determine if these forces are equal and observe if the cart will move or not. Then, to analyze the situation, you may pause the video. So here we go. Look at the two teams. Who is your bet? In the first round, second round, ready, go. Third round. And now, the final round. This round will be the basis in determining the winner. Are you ready? Go! This time, you are going to answer the questions of the activity. You may pause the video to copy the questions in your activity paper and answer them. Your activity paper must have your name, grade level and section, title of the activity, and objectives. Copy the questions and answer. Observe margin. This time, you're going to perform an activity about inertia, which is Newton's first law. I'm going to demonstrate how to do it, so please watch carefully and attentively. Our objectives are: okay guys, this time I'm going to demonstrate to you how you are going to perform an activity on investigating inertia. The title of this is a coin drop. So you need the materials, a 5 peso coin, a cardboard, and of course, the glass. So what you're going to do is you lay the cardboard on top of the glass and Be sure you have one edge of the cardboard a little beyond the rim of the glass so that you can give an edge a good flick to the cardboard. And aside from that, it will prevent your finger from smacking on the glass. So you place a penny on top of the glass or on top of the cardboard. Do not flick the cardboard like this or like this because you cannot get the good result. First, you have to flip slowly so that you will know what will happen. Like this. Okay? That's flicking slowly so you can see what happened to the coin. This time, you have to flick at the edge of the cardboard quickly. Pause the video and do the activity yourself and answer the questions in your activity paper. The next activity that you're going to perform is about Newton's second law. Picture analysis will be used in this activity. Our objectives are analyze the drawings and find out what is the speed, acceleration, and force of the moving objects. Fill in the table for easy analysis of its figure. You may pause the video to study the illustrations. In the table, you can find there in the first column the picture number 1 to 6, followed by the mass, the force applied, the speed, and acceleration. Here we go. Illustrations for analysis, set A. Picture 1, the man is pushing the box. The arrows indicate the direction and magnitude of the force applied and the friction. Record the mass, speed, and acceleration in the table. Picture number 2. Compare this picture with picture number 1. Observe what is added and the force applied. Take a look at the speed and acceleration. Are there changes? Record the data in the table. Picture 3. What is the difference of this picture with the previous two pictures? What is increased and what made constant? What happened to the speed and acceleration? Set B pictures or illustrations are picture number 4. Set B illustrations have different scenarios compared to set A. Try to spot the difference. Record the mass, acceleration, speed, and the force applied in pushing the box. Picture 5. What is the difference of this picture to that of number 4? What is increased in this picture? Is the mass the same? And the last, picture number 6. Is the man pushing the same object? Is the force increased? As a result, what happened to its speed and acceleration? Now guys, it's time for you to answer the questions in the activity. pause the video and start answering it. I know there are still clouds in your mind after performing the activities. Let me explain what you have done so you will appreciate the application of the concepts in your daily activities. Recall that our first objective in this lesson is to differentiate balanced and unbalanced forces. That is why in your activity for this objective is entitled Making the Balanced Unbalanced. Do you remember the cart full of groceries won by the red team? Newton's first and second laws need the concepts of balance and unbalanced forces to understand better these principles, especially its application to our daily life. For better understanding, please refer to the comparison chart about balance and unbalanced forces. We have 1, 2, 3, 4 bases for comparison based on the chart. First is magnitude and direction of forces. The second basis is effect of these forces to object in motion, effect of these forces to object at rest, and the net force. So for the balanced forces, in terms of magnitude and direction, in balanced forces, it's equal in magnitude, but in opposite direction. For unbalanced forces, the magnitude are unequal and opposite or made the same in direction. For the effect to object in motion, balanced forces, if it is applied to object in motion, the object continues to move in the same speed. But if unbalanced forces are applied to object in motion, the object or the moving object changes its speed and direction. If balanced forces are applied to object at rest, that object stays at rest. If it is the unbalanced forces applied to object at rest, the object will move in the direction of the greater force. For the net force, balanced forces have zero net force, while unbalanced forces, non-zero net force. Let's go back to our activity. When team wins the cart full of groceries, or what team wins the cart full of groceries? Yes, the red team. In the first and second rounds of the game, the cart did not move. Why? The reason is the forces applied by both teams were equal in magnitude and the direction is opposite. However, in the final round, the red team had only 2 players, but their forces is greater than the blue team with 3 players. So, the red team was able to pull the cart towards them. In the activity, it shows that the direction of the motion of an object follows the direction of the greater force. Therefore, we can say that balanced forces applied to the object in opposite direction makes the object to stay at rest, while unbalanced forces makes the object move following the direction of a greater force. Newton's first law is also known as the law of inertia. It states that an object at rest will remain at rest unless acted on by an unbalanced forces. An object in motion will continue to move at constant speed and direction unless acted on by an unbalanced forces. This law was also manifested in our activity on the game of blue and red teams because the card remains at rest when the forces applied by the two teams were equal. But when one team increased the magnitude of the force, making the forces applied unbalanced, the card moved towards the direction of the greater force. How about in your activity about investigating inertia? What happens when you slowly lift the cardboard? The coin on top moves with the cardboard. The frictional force acting between the coin and the cardboard caused the coin to stay on top of the cardboard and move with it. How about when you lift quickly the cardboard? When the cardboard was lifted quickly, the cardboard moved forward, but the coin did not move with it. The coin stays in one place and dropped into the glass because the gravity acts on it. In addition, the coin did not move forward because of inertia. Inertia is the tendency of the coin to stay at rest. For better understanding, take a look at this. An object at rest will remain at rest. That's the ball. Unless acted on by an unbalanced force, maybe through kicking the ball. An object in motion will continue with constant speed and direction unless acted on by an unbalanced force. So that is all about Newton's first law. How is this law related to the second law? Newton's second law states that acceleration is directly related to force and inversely related to mass. In your activity on simulating Newton's second law, the variables that were manipulated were the mass and force. The table shows your results. You pause the video and study the table. Answer the questions on the next slide. So as a result of your activity, set A pictures 1, 2, 3, set B pictures 4, 5, 6. Consider this scenario. The man is pushing the cart with a load of a box. Observe on the change in acceleration of the cart. Pause the video for you to analyze the picture carefully. What is constant in the picture? Is it the load, force, or acceleration? What did he increase? Is it force or mass? As a result of increasing the force, what happened to the acceleration while mass is the same? How about in situation number 2? Find out the difference with the first situation. What is constant in the pictures in situation number 2? What did the man increase? What happened to the acceleration when the mass is increased while the force is the same? Remember this. In Newton's first law, balance forces cause the object at rest and in motion to stay at rest or continues to move at constant speed. It is the unbalanced forces which cause the object at rest to move, an object in motion, to change its acceleration and direction. In Newton's second law, force and mass of the object are related to the acceleration. Greater force, lesser mass, means greater acceleration. In equation, this can be expressed as acceleration is equal to force divided by mass. In symbol, A is equals to F divided by M. To elaborate further about these laws, let us apply in our life. Maybe you will agree that in most of our actions or activities and even decisions in doing something, Newton and first and second laws are not considered, especially the risks. That is why the title of the activity that you will do is too risky. Just like what is shown in these pictures, pause the video and analyze the situation. Answer the questions. In the previous activity entitled Too Risky, maybe you have realized how important are the concepts of Newton's first and second laws in the activities that you do every day. Let us explore further by answering the next activity entitled It's in the Law. Determine if the scenarios stated are related to Newton's first or second laws. Mark a check that corresponds to the law. You pause the video and answer this. Ready? Start. I know at this time you already understand the two laws of Newton. Let me check your comprehension. In this activity, you are to relate to the following situation which usually happen when you ride in our local transportation like multi-cab, tricycle, or any vehicle available in going to school or anywhere we want. Which of these did you experience? What did you do to protect yourself? Pause the video to answer this. Bravo! I know you learned many things and concepts in Newton's first and second laws. So we'll check your critical thinking by answering this. A big truck stuck on a muddy road. The driver challenged the bystanders to push the truck out of the mud because he is going to give a prize. If you are there, would you join? Explain your decision in relation to Newton's first and second laws. Write your answers in your activity paper. So guys, until next time, see you on the next video.